Hello everyone, welcome to the 8085 instructions series. So in the previous session we studied the various arithmetic group of instructions. We started with A double D and got up to ADA. Now we'll start with this ANA. Okay, this logic instruction in this case starts from ANA up to STC. So these are the various logic instructions. We'll study this for 15 instructions actually. So we'll study them with example. Okay, so let us see the example first. So we'll study this logic groups, that is ANA, ANI, ORA, ORI, then XRA, XRI, and CMA. Let us first see the example. Okay, then we'll execute and check the result, verify the result. So we'll use this example. We'll store some data in A, B, C, D, and then observe this instruction. So we'll store C2 in A, D3 in B, A6 in C, 92 in D, and we'll execute this instruction A and AB. Now A and A means logically AND the contents of register A with B. ORA means logically OR the contents of register A with C. XRA means logically XOR the contents of register A with D. See, in any logic operation, A is one of the operands and an other can be any other register. Now let us see what happens with A and AB. So A contains C2 and B contains D3, and with A and AB this will happen. We just write this data in binary, okay, express this in binary and do the bitwise operation. So 0 and 1 is 0, 1 and 1 is 1, so we get this final result. We get C2 again. So after A and AB, with this 2 ending, we will get C2. So note down this data, this result, so then when we execute we'll get the same thing. Then with ORAC, whatever was in A, so we got A as C2 in the previous operation, after the previous operation. With A6 we OR the contents. After ORing we get this as 1110 0110, so the result will be E6 and this will be stored in register A. Now next operation is XOR A. XOR A will XOR the contents of A. Now A becomes A6 after the previous operation and 92. After the XOR operation, the result we get is 74. Okay, so this we will get in the registers. Then let us continue with this. So next we will do ANI, ORI, and XRI. Now the ANA, ORI, and XRI, they are 1 byte instruction. Now this ANI means AND immediate, ORI means OR immediate, XORI means XOR immediate. So ANI will AND the contents of register A with the data D3. ORI will or the content of register A with register with the data A6. XORI will actually XOR the contents of register A with this data 92 and store the result in register A. So we'll get the similar result as we got. Okay, and the difference is that we are just giving the data, we are not storing the data in any register, but we are giving it immediately directly. Okay, so this we will get the result. Okay, then finally we have a CMA instruction. CMA means complement the contents of accumulator. So this is only for A. It actually flips the bits of register A 0 to 1 and 1 to 0. So suppose if A contains FF, okay, F is 4 ones, okay, and next F is again 4 ones, so 1 1 1 1 1, and if we do the CMA it will become all 0 0 0, so it will contain 0 0. Now let us store this data in the simulator and execute this. So now I have stored the data MVI AC2, MVI B, D3, MVIC, A6, and so on. So we'll do this operation A, and let us check what we get after A and A. Okay, so with the first step we get this C2 in A, with the second step D2, D3 in B, A6 in C, then 92 in D. As you can see, we are getting the answer as C2, which we got when we are doing that, we did it. Okay, and then we are getting E6 as expected, and exactly we get 74. Okay, so this is how this operation is performed. Okay, now let's go for the immediate. Okay, so here we have this MVI A, ANI, ORI, and XRI instruction. If we go by stepwise, okay, with this first step we get C2 in A. With the next step, this data which is in A, it actually ends with D3 and stores in A. Okay, and we get the next result ORI A6. Okay, and then finally XRI 32 we are getting 74, which we are expected. Okay, now let us go for more instructions. Next we load FF in register A and give the instruction CMA. It will complement this content so that A will become 0. Now let us execute. So with the first step we have FF in A. Okay, With the next step, it complements, so FF becomes 0 0. Okay, so this is only for register A, 1 byte instruction. The next logic instruction we will see is the compare instruction. Okay, so for studying that, we'll load some number in register A, B, C, D. So this we are loading 59 in A, 47 in B, 89 in B, C, and 59 in D. And this CMP instruction, so what does this instruction do? This instruction actually compares the contents of register A with B. CMP in C, it compares the contents of register A with C, and of course CMPD compares the contents of register A with D. So we can compare the content of any register with register A. Okay, now I have taken 3 datas in the registers B, C, D. One which is less than the content of A, one which is more than A, and one which is equal to A. Let us see what happens when we run this. We just load these numbers and run this code. Okay, let us see on the simulator. So here is the code which we will use for studying the compare instruction. Okay, so with the first step, as we can see, 59 gets loaded in A, 47 next step gets loaded in B, 89 in C, and 59 in D. Now let us happen what happens when we do the CMPB instruction. Okay, so with CMPB instruction, it compares the contents of A with B. Okay, as we can see, the contents are not changed. A is 59, remains 59, B remains 47, and here we can see that the 0, here we are concerned with the 2 flags, 0 flag and the carry flag. So 0 and carry both are reset. It means that when we are comparing the contents of any other register or memory location, if the content of A is greater, then neither the carry is set, neither the 0 is set. Both are 0 0, both are reset. Okay, then let us go to the next step. Now in the next step, compare C. Okay, it will compare the contents of A with C, and you can see the contents are not changing, but here what we observe is that the carry flag is set. Okay, but 0 is reset. So whenever we are comparing the content of A with any register or memory location, if carry gets set and 0 is reset, it means that the content of the other register, in this case C, is more than A. Okay, now let us see the last step, the compare D. In compare D, the contents of A is equal to compare of D, and for that case 0 flag is set and carry is reset. Okay, so when we are comparing the content of A with any other register or memory location, and if the contents are same, the 0 flag is set. So this is how this CMP instruction works. Then there is one more instruction. Let us see that. So we have, in this case, we have CPI instruction. Okay, so this CPI, as you can see, CPI, it is called as compare immediate. Okay, now compare immediate, it compares the contents of register A with the 8-bit data. Okay, now it can happen that the 8-bit data which we are comparing is smaller, greater, or equal to. So if that content, 8-bit content, is greater is less than A, then neither the 0 flag is set, neither the carry flag is set. And if they are equal, 0 flag is set, carry is reset. And if the 8-bit data is more as compared to A, then the carry flag will be set and 0 will be reset. That you can test it. Now let us go to the other instructions or logic instructions. Now next logic instruction is the rotate instruction. So this rotate instruction, it rotates the contents of register A, either left or right. So here we have 2 instructions. Actually there are 4 instructions, 4 rotate instructions, 2 for rotate right, 2 for rotate left. So one is RAL, it is rotate accumulator left through carry, and RLC, rotate accumulator left. So we consider an example. Suppose there is some data AA in register A. Now AA means A is 1010 and another is 1010, and let us assume that carry is reset. Okay, the carry is reset. Now what happens when we with this particular data, as we can see, this is the data. Okay, so with this particular data, okay, A contains AA. Okay, and this carry is set. What happens actually is, 1 minute, I will just transfer the data here. Okay, this is the data. Okay, so suppose A contains AA, okay, and carry is reset. We give this instruction RAL. Now with RAL, this D7 bit, okay, this is the D7, okay, it goes to this carry bit, okay, and this carry bit, it goes here, okay, and all the other bits, they transfer 1 bit towards the left side. Okay, so it is going through the carry. So after this, what will happen is that this 0 gets transferred on the left side, this 1 to the left side, and so on. So what we get is 0 1 0 1 0 1 0 0, sorry, and carry is actually reset. Okay, so this is what we get. Carry is set. Okay, so the data in A is 5 4 and carry will be set. Now with RLC, what will happen with RLC? Let us see what happens with RLC when we write this section RLC. We start with the same data A. Okay, in register A, carry is reset. With RLC, what happens actually? This D7, it goes into carry, and this D7 also goes into the D0 bit. Okay, rest is same. Okay, only this bit it goes into carry and also into the D0. Carry is not transferred to the D0 bit. Okay, so after this what we have is 0 1 0 1 0 1 0 1. It is 5 5 and carry will be set. Now let us execute this on the simulator. Similarly, actually we have this RAR and RRC. RAR is rotate accumulate right through carry, and RRC is rotate accumulate right. Okay, it functions similarly, only the difference it rotates right. Okay, now let us execute this on the simulator. So towards the left side is the code we will execute to this demonstrate the working of this RAL and RLC. So first what I did is loaded A in A, then RAL, then again loaded A in A and RLC. Let us see by executing. With the first step, AA gets loaded in A. With the next step, RAL, okay, the leftmost bit, that is a D0 bit, okay, it transfers to carry, as well as it only gets transferred to carry, and carry gets transferred to D0. Therefore this data is 5 4 and carry is set. Okay, now with the next step again we have AA in A again, but with RLC what happens is that the leftmost bit also goes to D0 and also goes to the carry. So carry is set, but here the data is 5 5 and the previous was 5 4. So this is how this rotate works. Similarly, we can also verify the working of rotate right instructions. Now we are left with just two instructions with respect to the logical group. One is CMC and other is STC. So here we have written STC. STC means set the carry flag. Okay, so it will set means what? It will make it as 1. Whether it is 0 or 1, it will make it 1. And this CMC is there. CMC is, it will complement the carry flag. If carry flag is 0, it becomes 1. If it is 1, it becomes 0. So I will just use 3 instructions to demonstrate the working of this instructions. So with the first step, let us see what happens. With the first step, as we can see, carry is set. Okay, it sets the carry flag. So carry is 1. With the next step, it complements the carry. So carry becomes 0. Okay, let us one more. We have just written one more CMC. So it will again complement carry. Complements what? 0 becomes 1. 1 becomes 0. So now it becomes 1. Okay, this carry flag becomes 1. So this is how this STC and CMC flag this instructions work. So that's all for this particular session. Thanks for watching.